Alright, guys, welcome to another episode. Yep. We are live. We are live. We are live again today. Okay, guys, good morning, good afternoon, good evening, depending on where you are watching from and the time that you are watching from. This is Uncle Sam, and we're back again. This is my day 7 of going live on YouTube to talk about things related to maths because I love simplifying concepts and I want to bring my own idea about the concept of maths, exploring different topics. I want to bring it into YouTube so that you guys will have a feel of my own understanding. For joining, I've been doing this consistently for the past 6 days. This is the 7th day, and I usually go live Mondays, Wednesdays, and Friday by 4 p.m. Nigerian time. If there's any change to that, I'll equally let you guys know. So for today's episode of our live section, we're going to be looking at simplification in logarithm. On Friday, we finish up on indices and introduce the basic idea behind logarithm, where we also looked at the laws of logarithm. To me, logarithm is so fascinating because as soon as I cracked the basic idea, remember the whole point, my whole approach of exploring topics related to maths is this. I first of all don't dive into techniques and solving. That's not what I do. I first of all try to explore the idea, the topic as first an idea. What is the message that logarithm, in this particular case, wants to pass across to us? And from last week's class, we got to know that logarithm, just like indices, is just a way of expressing numbers. Just like in indices, I always refer back to indices. Indices has to do with index, comes from the word index, and index has to do with powers. So another name for index is powers. And then there can be power without something very important, which is what? A base. So you see how it's moving. For you to have indices, it reduces to index, and index is same thing as power, and there cannot be power without a base. So that is the basic idea that indices wants to pass across to us, is that you can reduce we can express a given number in terms of a base raised to a power. And the power tells us the number of times the base multiplies itself to give that particular number. That is the basic idea that indices brings to us. And then when it comes to logarithm, it's equally another way of expressing numbers. And in this form is of this form. So we express logarithm as log b of, let's say, x is equals to c. Now, the basic idea of logarithm is this. We have a number, and what we're trying to do, we know the base of the number. We're trying to find the number of times or the power in which the base can be raised to get the value. That is, to get the original number. Which is to say that this implies that the base here, raised to the power of c, is equals to what? B. So logarithm, in summary, just seeks to tell us about power. We are trying to get the power that the base will be raised to give us the value of the log. That is the basic idea. And so, if that is the case now, we're now going to get into what we have for today, which is simply simplification of logarithm. So I'm going to, while I solve problem under simplification, I'll still be pointing to the basic laws that guide whatever I'm doing. So the first question I'll be observing today is this. Look at this first question. Express 7 raised to the power of 3 equals to 343. Express this particular number in logarithmic form. This is the first task I was supposed to do. This is just to introduce us into how we simplify logarithm. And this is a good way to start the simplification. So express 7 raised to the power of 3. 7 raised to the power of 3 equals to 343. Express it in terms of what? Logarithm. So how do we go about expressing this in terms of logarithm? It's quite simple. The basic idea of logarithm is the solution. We know the general form of logarithm is that if I have log b to the base of x, it is equals to c, where your x is the base, your c is what? The power that the base must be raised to. And then your b is the value that is gotten when the base is raised to a power. So since we know that this is the general form of what? Logarithm, we can go ahead and simplify this by placing each of the expression here, each of the values here, in the designated place here. That is simply how you do it. So in this particular case, what is our base? Well, we're having a base of what? 7. So we can now replace this x here to be 7. So this is something as log to the base of 7. And then, what is the value that the base, when raised to a particular power, gives in this particular expression? Well, we know that is equal to what? 343. So that simply means that log 343 to the base of 7 is equals to our c now is now the power. In this case, it is what? 3. So if actually what? Express this in terms of logarithm. And moreover, this particular form is actually the reverse, because you know that for any given logarithm expression, log b base x equals to c, what is simply trying to tell us, it implies that our b is same thing as x raised to the power of what? C, which is already what we had from the given expression. So what we simply did was we worked our way backward to get the original what? Logarithmic expression. I hope this makes sense, guys. Welcome. Thank you guys for joining. Really appreciate you guys for being here. Thank you. So this is the basic form. So this is the logarithmic what? Form of this expression. So the first thing you need to do, locate the base. The base is usually underneath here, and then the log is usually the number that the base, when raised to a particular power, gives you. So that is the number that is attached to this b. It's equivalent to your b here, and then the power on top is equivalent to your what? C. This is it. So let's go on and solve another problem. This particular problem just involves the basic idea of what logarithm is all about. So let's talk about another problem that's quite interesting. So I'm going to clean here. In 5, 4, 3, 2, 1. Please take a screenshot if you may. Take a screenshot, and I'm going to clean it so that I can write the next question. All right. So let's go on and solve the next question. We have simplify. Remember, we're doing simplification. Our major focus today is simplifying logarithmic what? Expressions and applying the laws. By simplifying, we're applying the basic laws of what? Logarithm. So simplify. We're asked to simplify log root 2 base 7 plus log root 18 base 7. We are asked to simplify this word, particular log. So what do you think we're going to do in this particular expression? Well, according to the law of logarithm, which I actually treated on Friday last week, and the live is actually on my page, you can just go on and see the live section the last live session that I had. You see introduction to logarithm. I spent a lot of time to explain the basic laws of what logarithm. So that is what we're going to be applying. So for a quick recap, when you have addition of two log, it simply means that once they have the same base, here they're having the same base, you multiply their log. So the format, since if we have log b base x plus log c base x. It is equals to, this is basic log, means it's equals to, pick one of the base, it becomes log to the base of x, and then multiply their what? Log b times what? C. That is basically what we're going to be applying in this particular example here. So let's go. Since they have the same base, it's going to be log to the base of 7. Then you can open a bracket and then multiply their individual, because that is what addition of logarithm simply means. So this becomes log of root 2 multiplied to what? Root 18, all to the same base of 7. You can only do this provided that they have the same base. This is the basic law of logarithm. So that is why you have to go through this route. So if you go on to multiply this becomes that log to the base of 7, and open bracket. This involves sort law. Sort said that if I have two root numbers and they are multiplying themselves, what you simply do is pick one umbrella or one root to cover them and then multiply the number. So this is simply as saying square root of 2 multiplied to what? 18. And once you've done that, this becomes log to the root of 36 base 7. And then we know that the square root of 36 is actually what? 6. So simplify, it implies that the simplified version of this expression is just log 6. 6 because the square root of 36 is already what? 6 to the base of 7. So with this now, we've applied the first law of logarithm, which is addition of log. We simply mean that since they have the same base, you just multiply their individual logs. That's how you do it. So that's the second examples that we'll be considering in today's class. We'll go on to the third one that we'll be looking at, which is quite interesting. So I'm going to leave this here and solve it in this particular side. So let's evaluate this one. Evaluate is something as what? Simplify. Evaluate log 49, no base here, divided by log 343. Yes, no base here. We just have log that we should evaluate log 49 divided by log 343. Now, one of the things that most people get scared of in logarithm is when you're given a log and it seems as though the base is not really attached there, so people get confused. And that's why I want to pause a little bit and explain something that is very, very crucial. In logarithm, there are like standards. Anytime you're given a log, let's say log 10, like log 50, and there is no base attached to it, it is assumed that by default, the base that is attached to this particular log is what? Base 10. Because that is the common base that we use, okay? That is what is assumed to be here. But it's not limited to this, but that's just the general fact. So take note of that. So if that is the case now, how do we go about solving this? Well, if we look at this sign separating the two logs, it is division. And from the laws of indices, we don't have like a law that states that we can use division. We only have addition law, addition or product law, and then subtraction or quotient law. Okay, but here we're having division. So this simply means that we're just going to simplify. What is our idea of division? We're going to find out here. So if you look at this expression, one of the things that I can start doing immediately is to just rewrite this as log 49. Then this division becomes all over. Yes, basic math. Division is over. Log 343. That's one of the basic things that I can start doing immediately as soon as I see this. Now, since I told you that anytime you don't see any base attached to any given number, it is assumed that what? The base is actually 10. So you can choose to bring that in, or you can choose to just work with this because this is actually simplifiable. So what can we do here now? Well, I can employ the power rule under logarithm. I know that 49 can be reduced to something raised to a power, a base raised to a power. And that is what? 49 is something as 7 times 7. And 7 times 7 is something as what? 7 squared. So, and also 343 is something as 7 times 7 times 7, which is something as what? 7 raised to the power of 3. So you see that I can replace these two value here, which is 49 and 343, with 7 square for 49 and 7 cube for 343. So once I do that, it now becomes, a simplified version of this becomes log 7 squared all over what? Log 7 cube. And we're getting somewhere. It's becoming quite interesting at this point. So what can we now do here? Now remember that indices, there is a law that states that if I have log to a base, and then I have b raised to the power of n, which is what is known as your power law. It's same thing as what? Taking the power and multiplying what? The log. So this is same thing as any log b base x. Yes, that's the same thing that is happening here. Okay? So what are we going to do here? The powers of each of them will go and multiply each of the log, both for the numerator and what? Denominator. Remember, please don't get confused. I told you, since here we're having a base, and I told you that by default, these two will have what? A base of 10. And I said you can decide to put it in. Anytime there is no base visibly attached, by default, the base that is there is base 10. So take note of that. You can actually put it or you can leave it. Because we're simplifying, I choose not to put it. You can do that if you want. It is still going to cancel out in the end. So if this power comes and multiplies this, it becomes 2 log 7 all over 3 log 7. So you now see why I say that it's not really that important whether you put it or not. Because if I still put base 10 here, or from here, add base 10 here, it will still end up the same way. Because at this point now, since log 7 and log 7 is common to both the numerator and denominator, they can what? Simply cancel out. So that the simplified version of this word expression is just equal to what? 2 over 3. So still on simplification. So the basic idea has been established, which is simplification of logarithm. That's it. 1 plus 1 equals 2 is simple math. That is just like 1 plus 1. Yes, Ryan, thank you. Brilliant. Thank you. Thank you. So that's it. That's the third question that I will solve so far. And we're employing the basic laws of logarithm in solving this question. Please take a screenshot because we'll have more questions to solve. Patrick! Thank you, Patrick. Good evening. Welcome. It's evening here in Nigeria, so welcome. So I'm going to claim here, and then we go on. We'll have plenty of questions because today's class is dedicated to simplification of logarithmic expression. That is what we are going to be doing. And we've been having some basic examples. We're not going to go into something a bit complex than the usual. Or let's solve one more easy question before we go into a complex one. So look at this one. We have log 4 base 2 plus log 16 base 2 plus log 8 base 2. So you see log 4 base 2, log 16 base 2, log 8 base 2. And they are all being added to each other. And then what do? It's still the basic law of logarithm, which is simply what? Addition. If you have addition of the log, it simply means multiplication of what? The individual what? Logs, provided that they have the same base. So as you can see here, all of them have the same base. We're going to get to a point where they don't have the same base, and you see what we're going to do at that instant. So what I'm going to do here, since they have the same base, solution, you pick one of the base, log to the base of 2. And then you simply what? Addition now change to multiplication, and you multiply each of the logs. So this becomes 4 multiply to 16 multiply to 8. So I'm going to do that quickly. 4 multiplied to 16 is going to give us 64. Then 64 times 8, 8 times 4 is going to give us 32. And 8 times 6 is going to give us 48. 48 plus 3 is going to give us 5, 1, 2. So that's what we have. So we have 5, 1, 2. So this now becomes log 5, 1, 2 base what? 2. So the next time, this we're done here, but we can actually go ahead to simplify this. 2 raised to the power of what is going to give us what? 5, 1, 2. Because I want to simplify this further. Let me find out immediately. 2 raised to the power of what is going to give us 2, 5, 2. A moment. A moment. Is there such a number? Okay, I think I've gotten it. I've gotten it. So we have that 512 can also be expressed as log 2 raised to the power of 9 then base 2. And so we apply the basic power law again, which is that if you have a log that is raised to a power, the power comes and multiply what? The log. So this is something as saying what? 9 log 2 base 2. And then what can we do here? Log of any number to its base is part of the laws of indicial, the special cases. Log of any number to its base. If I have log b base b is equals to 1. And there's a proof to this. There's a proof to this. Why? Because remember that the basic idea of logarithm, log b base x equals to c, is that if I take the base, which is x, and raise it to the power of the c here, it is equals to b. So if you are to verify that here, is it going to be the same thing? Take this base, which is b, raise it to the power of 1. Is it equals to b? Yes, because anything raised to the power of 1 will still give you back the same thing. So that's what we have at this point. So that this tells us that log 2 raised to 2 is equals to 1. So this is something as saying 9 multiply 1. And the simplified version of everything here, the summation of these logs gives us what? 9. So we've actually done the what? The simplification of this expression. So yeah. Please, if you have any question, you can actually leave it in the chat and I'll attend to you specially. So we're going to questions that are more interesting, much more interesting now. Yes, there are ones that we need to do some extra work before we can go about the simplification. So look at it. Evaluate log 4 over 9 4 over 9 base 2 over 3. Yes. Evaluate log 4 over 9. This is a fraction. The log is a fraction and the base is equally a fraction. So, how do we go about solving this? Well, this is quite very easy if you look at it. Do not be swayed by the fraction that you see there. It's quite easy. Now, one of the things that you're going to be, one thing that you'll be looking at to do here is, when you see an expression like this, tell yourself, ask yourself this question: is there a way that I can replace the log or reduce the log to have a base, to have this kind of base, and then raise to a power? Well, we can, because it turns out that 4 is same thing as 2 squared, and 9 is same thing as what? 3 squared. So we can actually replace this 4 over 9 to be log 2 squared over what? 3 squared base 2 over 3. This is one of the things that we can do at this point. And so what is the next thing that we can do? We can apply what? The law of what? Indices. Where if you have two expressions with the same power, we can what? Bring the power outside and use a bracket to cover it. So it's simply saying log 2 over 3, everything raised to the power of 2, and then you have what? Base 2 over 3. So at this point, we have made what? Both the log and the base to have the same value. And then we'll go on to apply what? The power rule of logarithm, which is, since the power is 2, take the power and multiply what? The log. So this is still the same thing as simplification that we're doing here. So it becomes 2 log 2 over 3 base what? 2 over 3. And then we'll go on to apply the same rule here, which is if I have a log that has the same value as the base is equal to 1, and I've already given you the proof to that. So everything here becomes 1. So this becomes 2 multiplied to 1, and that is equal to 2. Again, we have simplified the logarithm expression in a way that is very, very easy to assimilate. Now, I'm going to do a reverse of this, so that you don't get stuck that it will always present itself this way. What of if you're asked to evaluate is same as simplify, evaluate log 9 over 4 base 2 over 3. What if you're asked to evaluate this particular problem? What would you do? Well, we're still going to take the same route, but we're going to do something very, very interesting here. Yes, something quite interesting. So first of all, we're going to reduce the individual expression here, just like we did here. So it becomes log of 9 over 4 is simple as 3 squared over 2 squared. Yes, 3 squared 9, 2 squared 4, then to the base of 2 over 3. We can reduce it like this. And then the next we can do, we can factor out the power. Since the power is common for both the numerator and denominator, we'll factor out the power, push it outside. It becomes log 3 over 2, then having a common power that will push outside, and then base 2 over 3. That's what we have. Now, well, it's not giving us exactly what we want, but we can actually continue this way. After now, I'm going to show you another way that you could have done this. So it's also very, very important. So at this point now, we can do something quite interesting, because mathematics actually allows us to do that. We can choose to invert this expression. Yes, I can choose to invert this 3 over 2 to now become 2 over 3. The only thing I need to do is, if I invert this expression, I have to what? Have an indicator that shows me that I have actually inverted this. So it's something as saying that this will now become log of 2 over 3 raised to the power of negative 1, and then there is an outermost power of 2, then base of what? 2 over 3. Now, is this the same thing as 3 over 2? I've not really done anything wrong. I just introduced an expression. So let's go and verify whether this 2 over 3 is same thing as 3 over 2. Everything raised to the power of negative 1, because this negative 1 here, reciprocal, or also called inverse, is what tells us that this 3 over 2 is the same thing. So let me bring it out here and evaluate it separately. If I have that 2 over 3, that 3 over 2, because that's what I'm implying, that 3 over 2 is same thing as 2 over 3 raised to the power of what? Negative 1. How is that true? Well, let's go and find out. This 2 over 3 raised to the power of negative 1, I can decide to push the power inside, and then it will be shared by both the numerator and the denominator. So it's something as saying 2 raised to the power of minus 1 all over what? 3 raised to the power of minus 1. Yes. And so whenever you have inverse, it's same thing as what? 1 over that base, then raised to the power of the positive of the value that you have on the power. So this is same thing as 1 over 2 raised to the power of 1. And then all over, do the same thing here. 1 over 2, 3 raised to the power of what? 1. Now the reason I attach this one is to show you that most of the time we just leave that, we just say that if I have 2 raised to the power of minus 1, it's same thing as 1 over 2. But what if you have 2 raised to the power of minus 2? So it's good that you know the same process, that you know that the process applies for every power that is negative. That's one of the laws of indices. So that this is same thing as what? 1 over the base raised to the power of a positive value of the power now. So that's the same thing that happened here. The base raised to a positive power of what? The power. Positive power here, which is same thing as 2 raised to the power of 1. And the reason why we just leave it as just 1 over 2 is because anything raised to the power of 1 will still give you back the same thing. So that's the basic idea. So if that is the case now, this is what we have. We can go on to simplify this. How can we simplify this? So this is the same thing as saying 1 over 2, then bring this division up, divided by 1 over 3. And then we can go on to change this division to become multiplication, and according to the law of fraction, the right hand side expression, fractional expression, will be swapped. the denominator will come up and become the numerator, and the numerator will revert and become the denominator. So this is a basic law. It becomes 1/2, change the division to multiplication, and it becomes times 3 over what? 1. Which is, if you now go on to multiply, the numerators multiply and the denominators multiply, it gives you 1 times 3 will give you 3, and then 2 times 1 will give us what? 2. So you see that 2/3 raised to the power of -1 is still the same thing as what? 3/2. And we have to employ it here because we want to achieve a particular goal. That's just the summary. Natalia, welcome. Welcome. So with this in mind now, you see that we not just pick this out, it's still the same expression, because in math it's very much applicable. If something is same thing as the other, you can bring it in to replace that same thing. So at this point now, this -1, which is the power that shows us that 2/3 is same thing as 3/2, it will go and multiply the outermost power, which is what? These two out here, so that it becomes log of 2/3 now raised to the power of -1 times 2 will give us -2, then to the base of what? 2/3. And then at this point we can now go on to apply the basic law of logarithm, which is the power law. We say that if you have a power, it goes on and what? Multiplies or attach itself to the front of the log. So this is same thing as what? -2, which is the power here, log what? 2/3 base 2/3. This is what we have. And then we apply another law of logarithm. We say that if I have a particular log that has the same value as the base, I can go ahead and what? Cancel it out, because it's the same thing as 1. A log of any number to its base is equals to 1. So this is the same thing as what? -2 multiplied to 1. And that's equals to what? -2. So everything that we solved here has given us what? -2. You see that when it was just 4/9, it gave us what? 2, +2. But when we now inverted it, it gave us what? -2. So that's the basic idea, and that's how to simplify this kind of expression. Yes. So that is it. Please take a screenshot if you may, so that I can solve one more question, because today's class is just evaluation of question. So please take a screenshot so we can now continue. Okay, so I'm going to clean this up and then we'll continue. Alrighty. Let's go. So we're going to solve one more question before we call it a day. Evaluate 62. Evaluate log 62.5 base 5 minus log 1/2 base 5. This is what we have at this point. So let's go on and simplify this given expression together. So when we have the same base, this is subtraction, and subtraction is same thing as what? Division of the logs, provided I have the same base. So here they have the same base, so we can go on and do that. So pick one of the base, log to the base of 5, and then open up a bracket, divide this. This is not saying 62.5 divided by 1/2. This is what we have here. So what do we do next? Well, we can go on to simplify this 62.5. I know that 62.5 is same thing as 625 divided by 10. So I can change this to become that. So this is now the same thing as log to the base of 5, and then 625 all over 10 divided by 1/2. That's what we have. So at this point, this becomes log to the base of 5. Then this division is going to now change to multiplication. That's what is going to happen. And this, once it changes, this 1/2 will be inverted. The 2 comes up, the 1 goes down. So this becomes 625 over 10 multiplied to 2/1. So this is what happens. And once you've gotten to this point, these two divide itself and divide 10 to give us 5. And then we can go on to divide. If 5 divides itself, it gives us 1. 5 divides 6, 1. Remainder 1. Put 1 here. Then 5 divides 12 will give you 2. Remainder 2. Put the 2 beside 5, becomes 25. 5 divides 25 will give us what? 125. So in summary, 5 divided 625 give us what? 125. So what we have remaining here is log of 125 to the base of 5. But we're not done yet because this can be simplified further. How do we simplify it further? This is same thing as log 5 raised to the power of 3 base what? 5. Yes, because I can express 125 as 5 to the power of 3, which is 5 times 5 times 5. And it can still give me what? 125. And so once I've gotten to this stage, next thing to do is apply the power law. Once the log is having a power, push the power to the front of the log. So this becomes 3 log 5 base 5. And then we'll apply what? Logarithm of the same base. So once a log has the same value as the base, it is equals to 1. So everything here equals 1. So this becomes 3 multiplied to 1, and that will give us what? 3. That is it. So we'll solve about 6 questions on simplification of logarithm, basic simplification of logarithm. On Wednesday, we're going to come back again to now examine more problem and then dive into logarithmic equation, because that one is going to be what? Very, very, very interesting. So thank you so much, guys, for staying up to this point with me. Remember, you can always reach out to me. Check me out on TikTok using the username at Uncle Sam 160, and then you can reach out to me on Facebook and Instagram with the username Uncle Sam Online Tutorial. Yes, and also you can contact me on WhatsApp using this number on WhatsApp. You can contact me, this my contact address. You can contact me on WhatsApp if you need any form of help, maybe on research or private tutorial on math. So I'm open to that. So thank you so much, guys, for joining today's episode. See you on Wednesday by 4 p.m. Remember, my live is on Mondays, Wednesdays, and Fridays by 4 p.m. Nigerian time. That's when I go live. So see you on Wednesday. Bye.